Hello, today we're going to work with parallel and perpendicular vectors in parametric form. So vector equations are parallel if their directions are the same. And that means that the b component of our two vectors are the same or some multiple of each other. So suppose we had x is 1 plus 5t, then the direction is defined by 5. In 3 dimensions, if vectors are parallel, they could occupy the same plane, and such vectors are coplanar. So this is wrong here. This should say not all coplanar vectors are parallel. They could intersect within the plane. So here I've got some sort of plane. I specifically chose a picture that is not representing the x, the y, or the z plane. I'm showing you that we get a plane is just any set of coordinates that are kind of flat. And we call that a plane. So here I could have this vector here, and then that vector there, and then this one here, and of course these are not all parallel. We could have parallel vectors in the plane, but we don't have to. Now there's some fancy words. We're going to learn parallel and skew and a few others that help us understand these lines in 3 dimensions and different planes. So for the lines x is minus 2 plus 2t, y is 1 plus t, and z is 4 minus 2t, and we've got x is 1 plus 2s, y is 3 plus 2s, and z is 2 minus 2s. Determine, first of all, whether they're parallel. Okay. To determine whether lines are parallel, we know that they're vector kind of equations. The b component has to be a multiple of the other one. At the moment, though, it's not in that form. So we're going to look at the direction numbers in each of the vectors. So the direction, this is the original bit of x, and this is the direction. The original direction, original direction. So let's consider each of the direction vectors in the x, y, and z components individually. So in the x component, it's 2 and also 2. The y component, it's 1 and minus 2. Oh, sorry, 1 and 2. And in the z component, it's minus 2 and minus 2. Now, if we were to put this in a Cartesian form or in a vector equation form, the direction would have to be the same in the x and the y and the z for it to correspond to lines being parallel. So since these are not equal to each other, then they're not parallel. So intersecting parametric vectors. So two lines will intersect if there is a unique variable that satisfies all of the equations. So they intersect if there's some value t that satisfies all of these equations. To do that, we're going to equate the x and the y and the z components. So minus 2 plus 2t equals 1 plus 2s, and then 1 plus t equals 3 plus 2s, and 4 minus 2t equals 2 minus 2s. So these are simultaneous equations. It's two equations in 3 unknowns. If we do that, you get, so if we call this equation 1, equation 2, and equation 3, if we simultaneously solve equations 1 and 2, we'll actually get t is equal to 1 and s is equal to minus a half. Now if we substitute that into equation 3, 4 minus 2 times 1 is 3, and 2 minus 2 times a half, or times minus a half, is 2 plus 1, which is, so t is 1, 4 minus 2 times 1 is 2, and then 2 minus 2 times minus a half gives us 3. So 2 is not equal to 3, so therefore these lines do not intersect. Okay, skew vectors. So if vectors are neither parallel nor they intersect, then they are said to be skew. So we've just proven that they're not parallel and they don't intersect, so therefore skew as not parallel and don't intersect. Okay. Perpendicular parametric vectors. Now, both vectors that intersect and vectors that are skew can be perpendicular to each other. So even if they don't go through each other, they can still be perpendicular to each other. I've got my two arms here, and I move my arms away. They're still perpendicular to each other, but they're not touching each other, so they still can be perpendicular or orthogonal to each other. And of course, if my arms are touching, they're perpendicular and at right angles. So let's determine whether these lines are perpendicular. So let's say I've got these two lines. So we've got, let's say, we've got x is minus 2 plus 2t, y is 1 plus t, and z is 4 minus 2t. Why don't we figure out what the direction of these vectors could be? Well, these are the directions 2, 1, and minus 2. So let's say A is the direction vector of the first line, and it's 2, 1, minus 2. So we'll set t to be 1. At the same time, it's going to be 2, 2, minus 2 is going to be the direction vector in the other direction, in the other vector. 2, 2, minus 2. We know vectors are perpendicular if their dot product is 0. So A dot B, let's find the dot product of these two vectors. So 2, 1, minus 2, dot product 2, 2, minus 2. If you do that, you get 4 plus 2 is 6, plus 4 is 10. So therefore not perpendicular. Okay. Example number 2 for today. Is we've got if L1 is x plus 3t, y is 2 plus 6t, and z is 1 minus 3t. We've got L2 and also L3. Show that L1 is parallel to L2. To do that, to find whether vectors are parallel in parametric form, we're just looking at the ratio of their direction vectors. So 3, 6, and minus 2. So 3 over minus 2, 3 over minus 2 here, 3 over minus 2 is equal to 6 on minus 4, which is equal to minus 3 on 2, which is true. Those are all minus 3 on 2. Therefore, it's parallel. Part B, show that L1 and L3 intersect. Let's find the direction vector of each of these vectors. So for L1, we've got 3, 6, minus 3. So that's the vector that's representing the direction of my vector, and the 1, 2, 1 is where it starts. L2 is going to be, where's L2? Oh, we're doing L3, sorry. L3 is minus 1, 1, 1. Okay, and we want to show that they intersect. So when two vector lines intersect, they intersect when there's some sort of number that satisfies all equations at once. So if we equate x, y, and z for L1 and L1 and L3, so L1, we're going to have 1 plus 3t is equal to 3 minus r. And then we're going to have 2 plus 6t is equal to minus 1 plus r. And then we're going to have minus 1 minus 3t is equal to minus 1 plus r. Now, if you solve 1 and 2 simultaneously, you get t is equal to minus 1 on 9, and r is equal to 7 on 3. And if you substitute that into the third equation, so equation 1, equation 2, and equation 3, you get that 4 on 3 equals 4 on 3, so therefore they intersect. Okay, part C. Is L1 perpendicular to L3? Let's use those two numbers that I didn't use over here, and let's find their dot product. So I've just found those two direction vectors of L1 and L3, so let's find the dot product of those two direction vectors. L1 dot product L3 is going to be minus 3 plus 6 minus 3, which is equal to 0. So therefore they're perpendicular. Part D, what can you say about L2 and L3? Well, we know L1 and L2 are parallel to each other, and we also know that L1 and L3 intersect at right angles. So if L1 and L3 are at right angles and L1 is parallel to L2, then part D, L2 is perpendicular to L3, because L1 was perpendicular to L3, and since L2 is parallel to L1, then L2 also has to be perpendicular to L3. How many questions do I have? Quite a number of questions. Okay. Question 3. Line 1 passes through the point 1, minus 2, 4, and 5, 3, minus 2, while L2 passes through the point 3, 8, minus 2, and A, minus 2, 10, where A is a real number. Find the value of A when L1 is parallel to L2. Okay. The first thing we need to do is just find these two vector equations. So let's find equation L1. It's going to be 1 minus 2, 4, plus some lambda outside of. We're going from here to here, so it's going to be 4. 3 minus 2 is 5, and minus 2 minus 4 is minus 6. And L2 is going to be 3, 8 minus 2, plus some lambda. And we might call this lambda 1 and this... actually, it doesn't matter. Plus lambda... actually, yeah, it does matter. Plus lambda 1, we'll call this lambda 2. And we're going from 3 minus a, or a minus 3. Minus 2 minus 8 is minus 10. And 10 minus 2 is 12. And we want to know, well, first of all, they're parallel. That means that 4, 5, 6 is some constant, let's call it k, times by a minus 3 minus 10, 12. So we know, first of all, that 6 is equal to k times 12. So 12k equals 6, which means k is equal to 2. No, a half, sorry. So therefore, we know that 4 is equal to a half outside of a minus 3. So that means a is equal to 8 plus 3. Oh, a is equal to 8. Oh, I think I've done something wrong. L1, we've got 5 minus 1 is 4, 4 on A minus 3. Minus 2. No, I don't think I've done anything wrong. I'm just looking at my answers from before and it's different. So 4, 5 minus 6. Oh, that's because there's a minus there. There we go. So it's 4, 5 minus 6, which means that's minus here, which means this is minus 0.5, and that's there. And minus 8 plus 3 is minus 5. So A is minus 5. Part B. Perpendicular, that just means that 4, 5, 6 dot product A minus 3 minus 10, 12 is equal to 0. So 4 lots of A minus 3 minus 50 plus 6 times 12, 6 times 12 equals 0. So we've got 4A minus 12 plus 22 equals 0. So then minus 12 plus 22 is 34. So A is equal to 8.5. I think, no, minus 12 plus 22. Yeah, what am I doing? Minus 12 plus 22 is 10. And then subtract that over, you get minus 10, and then divide by 4, you get 2.5. So minus 2.5. Took me way longer than it should have. Okay. Next example, we've got find the parametric equations of the line through minus 2, 1, 2 that is parallel to this. So let's just write our vector equation. R is equal to minus 2, 1, 2 plus lambda outside of 2 minus 1, 3. Done. We've got to find the parametric equations. X is equal to minus 2 plus 2 lambda. Y is equal to 1 minus lambda. And Z is equal to 2 plus 3 lambda. Part B, do either of the points that and that lie on the line? To figure that out, we're going to do some simultaneous equation solving. So we're going to, first of all, go x is equal to minus 2 plus 2 lambda. And we're going, okay, that's equal to 1. Let's find the value of lambda now. So minus 2 plus 2 lambda is equal to 1. That means lambda is equal to 3 on 2. Then we're going to substitute each of these, 3 on 2 into each of these, and see if we get the values of y. So we're substituting in the value into each of these. So we've got 3 on 2. Now 1 minus 3 on 2 is minus a half, which is not 2. And 2 lots of 2 plus 3 times by 3 on 2 is 13 on 2. So no, this doesn't lie on the line. Let's do the same for the other point though. So we've got minus 6, 3, and 4. Now I'm just going to rub this out. So let's say, right, minus 6 has to equal minus 2 plus 2 lambda, which I think means lambda is 4. Yeah, oh no it's not. Minus 1, minus 1. So let's check. Oh, no, that's wrong. Minus 2. So let's check. Does 1 minus minus 2 equal 3? Yes, it does. Does 2 plus 3 times minus 2 equal minus 4? 2 minus 6 is minus 4. So yes, therefore, minus 6, 3, 4 lies on the line. Okay, part C says find the coordinates of 2 points that lie on the line in part A. Well, I've already found one, and let's just make lambda 1. Minus 2 plus 2 is 0. 1 minus 1 is 0. 2 plus 3 is 5. Okay. Next question. Find the coordinates of the points where it cuts the axis. Okay. So for it to cut, say, the coordinate planes, I read that wrong, sorry, coordinate plane. So let's say it cuts the xy plane. Now the xy plane is z is 0. So for this to be 0, lambda is minus 3. Then that would be 0. The xz plane, we've got no y values. So let's make this equal to 0, lambda is 2. And what are we going to do? We're going to do the yz plane. That's where the x is 0, so that means lambda is minus 1. Now let's find those points. So if we set lambda to be minus 3, you're going to get the point minus 2, 10, and then 0. If we set lambda to be 2 in this whole equation, you're going to get 3, 0, 5. And if we set lambda to be minus 1, you're going to get 0, 6, and 2. Cool, and that's it for that video. Thanks for listening.